So hi everyone. So today we are going to also look into the second program. The second program that we'll be studying today is a program to calculate the square root of the number by Newton's method. We'll just configure, go to the configure ideal option. Okay, and here I can increase the size. So I'll just make it to 14. So I hope now it is uh, looking better. Okay, so here this is the program to calculate the square root of any given number by Newton's method. So here we have taken 100 as the number. Okay, so first, as we studied in the last program, so we need to define a function called as Newton square root, and n is the number for which you have to find the square root. So basically this particular function uh, it mainly defines a function named square root that takes the parameter n into account. Okay, so you're giving a parameter n where that n is nothing but this particular number 100, for which you have to find out the square root. So then what you're doing is as per the Newton's method, okay, the first thing what you do is you initialize the approximation. So first you're going for an approximation, where what you're doing is you're just going with an approximate value. So whatever the n value is selected, you are multiplying it with 0.5, means you're reducing it to half. Okay, and then what you're doing is now that half is not your square root, so you have to find a better solution for it. Now what you do is you try to improve the approximated value or the approximation using the Newton's method. So Newton's method is that you're just giving a name like beta, because this is the approximated value and this is the beta value compared to this. Okay, so there's a formula called 0.5 into approx plus n. Now this n is nothing but the value that you have considered here, divided by approximate, and this is the basically formula for the beta. And after that what you're doing is you continue to improve the approximation until it stabilizes. So what do you mean by until it stabilizes? Until your approximate and beta values they are equal, you continue this particular loop. Okay, so that is what you're doing here. So that is why you have used a loop that continues until the approximation stabilizes. Now what is that? Your beta becomes actually equal to approximate value. So you have written here in the comments, so until your beta, the value in the beta, it becomes equal to the approximate value, you try and continue this particular loop, it will automatically continue. Okay, so and then you again define this particular formula, beta is equal to 0.5 into approx plus n divided by approx. Now once your beta and approximate values are equal, then what you do, you come back to you return to approximate value. Okay, now that is your square root. Okay, and then what you're doing is you're giving a print function stating that the square root is actually, and again defining this particular square function with the number for which you have to find out the square root. So this is the basic program that we will be running. Okay, I'll just run this program and we'll see what is the output we get. Then I'll go to the algorithm and we will see how this particular program is executed. So what I've done here is, for each function I've just given an explanation what are they actually doing here, but it is also very important to understand the algorithm and the logic behind it, because until you don't understand the logic, you will never be able to write another program which is much similar to this. Okay, so let us next try to understand the logic behind this program, but before that I'll try to run this particular program. Okay, I'll just run it. So your square root, see here the square root is 10. Okay, so now your program is correct, you've got a proper square root. So square root of 100 is 10. So this is fine, this is done. Now let us see how this program actually works, what is the logic behind this particular program. So here I've actually written the explanation for the program too. So I've divided it into steps. So the first step actually is to assume approx as half the number. Okay, so for example, if I take the 3 as n, means I need to find out the square root of 3. So I am taking an approximate value for it by multiplying it with 0.5. That actually gives me an approximate value of 1.5. Okay, then what I'm going to do is, I know this 1.5 isn't the square root of 3. So what do? I try to find a better value compared to my approximate value. So there I use this particular formula, better is equal to 0.5 into approx plus number divided by again approximate value. Now your approximate value for the first, this is the for the first iteration, okay, the approximate value is mainly basically 1.5. so that is what you're going to give here, and your number is basically 3. Okay, so this is very, very important that you should know, because anywhere if you input a wrong value, then your answer or your value for the better will be very wrong. Okay, then what is the step you're going to do? You are going to compare whatever better value you have got here with the approximate value. Okay, is my approximate value equal to better? And that is no way going to happen in the first iteration. Okay, so what you do is you do the step 3.1, that is, while better found is not equal to the assumed approximate value. So it is not equal, you have tried it. Okay, it normally, if you use this particular formula, it comes somewhere as 1.75, and 1.75 is nowhere near to 1.5, so they are not equal. So what you do, okay, you again recalculate the better value, but now what happens, this 1.75 becomes your approximate value. Okay, so that is what they've said, the better becomes your approximate value, and then you find out the better value. So now for the second step, for the second iteration, if I may say, better is equal to 0.5 into approximate plus number, that is 3, remains the same here, divided by approximate. Now what is your approximate? Your approximate is 1.75. Okay, so that is your approximate value for the second iteration, and then again you check if your better value is same as approximate. If not, you keep on calculating until your better and approximate are same, and at which moment you have a condition where your better and approximate values are same, so there you print the better value as the square root. Okay, now let us now let us do this with a proper example. Okay, now this is the formulas that I have written here. Okay, now let us do this with a proper example, if I may say. Now what I've done is I've taken the example of square root of 3, so the number becomes the 3. Okay, now what is the first step? First step is I multiply this 3 with 0.5. Okay, 0.5 I'm using here. I'm multiplying this with 3, so my approximate value, this is the first value for approximate. Okay, for approximate I multiply 0.5 with the considered number, so my approximate value at the first stage becomes 1.5. Now what I'm going to do is this 1.5 I am going to substitute it here to get my first better value. Now you can try to do this in your calculator, and you will see that the first better value is 1.7. Now is your 1.5 equal to 1.7? No ways, it's not same. Now what happens, this 1.5 becomes your approximate value for the second iteration. This is the first iteration, this is the second iteration. Now approximate is 1.5. now what do, you again substitute this 1.75 here in the place of approx and try to find out what is the better value. Now you get the better value as 1.7321 some number, so that is why I've kept it as dot dot dot, again the last 3 digits 572. Now this both are again not same, so I transfer this number to approx again for the third iteration. Okay, now once I substitute in third iteration, again I will substitute this approximate value into this and find out what is my beta value for third iteration, and my beta value becomes as 1.7320, some numbers and ending with 274. Again these both are not same, so I make this as my approximate value for the fourth iteration. For the fourth iteration I make this. Okay, now again I will substitute this in this approximate value and then try to find out the beta value. I get it as 1.7320772. now this is not again equal to this value, okay, they are both not equal, so I will substitute this again here in approx. This approximate value is there, right? This approximate value is again substituted in this approximate value and I get a beta value as 1.7320, some numbers 772. Now you see that this both are equal, so at the fifth iteration you will see that 1.7320 is equal to 1.7320. so what is that? I am going to stop my iteration, and now what is my actually square root of 3? The better value that I have got at the end. So this becomes my actually the square root of my 3, so you can call it as 1.73. that is more than sufficient, 2 places after the decimal. So 1.73 is the square root of 3. So this is how basically your what do you call this, Newton's basically the Newton's theorem actually works. Okay, and then if you see here for the program second, I have written the instruction wise comments for each of the things, or each of the command that I've used. For example, if I take into considerations Newton's square root, what it is also I've written, it is a function that takes one argument, that is one value of n, which is the number for which we want to find out the square root. Okay, then I initialize the approximation. So step by step I've clearly explained it, and if you're finding it difficult to understand this, you can always refer this particular explanation. This is also a valid explanation. So I've tried to give the explanation in both the forms. Okay, here I've also written the type of function they are actually using here. Okay, so this is the explanation for the finding the square root of the any given number using the Newton's method. It is very easy. Okay, until you don't try to solve it yourself, okay, you will not understand it. So try to take this particular example itself and try to solve it. Okay, once you get a hold of this, it will really become very much easier for you to actually understand. And even if you see the program also, it is very easy. First you are giving a function that has been defined, okay, and then you are actually telling that my approx is equal to 0.5 times n, and then you try to give the introduction to the formula. You're basically defining what is approx, what is actually better, and then you are telling that when I enter into a loop using the while statement, you're telling what is better. Okay, so then you're actually telling then what actually while better is not equal to, okay, this, then you're telling that it goes to this formula you have to use, and then if approx equal to better, then return to approx. That is what you're mainly telling. Okay, and finally you are actually printing the square root is Newton's square root with the value that is 100. So for 100 the square root is 10. Okay, so this is how you get the answer. As I've already told you, this is the shell window. Never try to run a code here. You cannot really run your code in this particular shell window. These are mainly used for single line commands, or it can be used for your calculator. For example, if I type 1 plus 2 and press enter, you can get the answer. Or if I try to print a function called hello world, I'm using a single quotes, by the way. You can also go with double quotes, it doesn't make any difference. Okay, so hello world comes in, but I can never actually go with multiple lines of quotes. If you want to use a multiple lines of quotes, I've already told, go to new file and click on the new file. you will get a scripting file like this, where you can type your multiple lines of codes. Okay, and if at any point of time you want to increase the size of the font, you just go to options and click on configure idle. You have various options here. Okay, so rather than actually going with or complicating things here, you can normally select 14 or 16 or 17 based on what font size you want. That would be that would be very much helpful. And here in the basically the scripting file, if you go to options, you can also type the show the line number. Now this line number actually helps you in a much better way to identify the number of lines of code, or in which particular line you are actually making a mistake. Okay, so this really sometimes helps a lot. So these are some of the things that you need to look for while actually writing a program. Okay, so this is the explanation for the second program. So in the coming days we'll try to explain all the different types of programs, followed by the basic instructions, from basic instructions to much more complicated instructions and programs in the Python. So we'll try to completely make a database of all the different topics that are included in Python, and which would be really very much helpful for you to follow, and we'll try to make this particular videos in as much simple way it is possible, so that you can understand. But one thing is for sure, that unless you type the codes, you are never going to get the feel of coding. Okay, first time, second time, third time you might come up with an error, but until you type it, you are not going to get into coding. Coding requires typing. How you need to solve the maths problem, in the same way you need to type the code. Okay, just by looking at it, just by mucking it up, you are not going to understand the code. Type the code. Okay, that is when you will feel it, and that is when you will learn it. Make the mistakes are not bad. Okay, the more you get the error, the more you will learn. Okay, try to make an intentional error. That will really make you learn, because the more the errors you know, you will become more good at solving the codes, or solving or writing any programs. Okay, because many a times, okay, we are so good in writing a program, and at some point of time, if we end up with any error, it becomes very difficult for us to identify what is the reason behind this particular error. So make errors. Now to make errors, you need to type the code. Okay, make sure that every day 1 hour at least, or maybe 30 minutes, you're going to type a code. Let it be anything, any random thing. Okay, just type a code, just do it, that's all. Just keep on writing the code, typing the code in your program. Okay, so that will be all for today. Okay, we'll try to catch up in more in the coming days. Okay, thank you.